Welcome to day 35 of reading for 30 minutes for every single day for the rest of my life. I almost screwed that up. Too. Okay. We have the alien perspective for tonight. And I'm going to set 30 minutes right now. Alright. I believe I'm at page middle of 96. Alright, here we go. 30 minutes starting now. Let's run it. Here we go. In 2010, 50 years after Project Ozma, astronomers got together to organize Project Dorothy, a 2-year scheme using different kinds of telescopes, including Green Bank, in 15 countries to look at 7 nearby stars, including Tua Ceti and Epsilon Eridani. Nothing was seen. Frank Drake commented, "It is thrilling for me to witness the beginning of Project Dorothy, the continuation of my search of 50 years ago. To have so many talented people using so many telescopes in this new search, with the electronics and computer equipment of today, is a joyful thing to me. The equipment of today is far better than what we could have 50 years ago, and will result in both very much better and very much more data than could be obtained then. Over the past 50 years, our searches have not yet produced the discovery we all hoped for. This is understandable. In our vast and awesome universe, it will take long, painstakingly, and comprehensive searches before we will have a good chance of success. This is the major lesson learned from previous searches. Long, painstaking indeed. The heady optimism of the Order of the Dolphin was long gone. Where were the aliens? What was needed was new funds and in a technological landscape populated by the likes of Elon Musk and his SpaceX company and Jeff Bezos with Blue Origin and their shared dreams of space exploration, those funds arrived in the shape of another billionaire. The new SETI funds have also been a huge catalyst for training scientists in SETI, says Jason Wright, director of the Penn State Extraterrestrial Intelligence Center, which opened in 2020 and is dedicated to looking for alien technosignatures, signs of alien technology or influence, named after Yuri Gagarin. Yuri Milner was born and educated in Moscow and worked as a particle physicist in Lebedev Physical Institute amid the collapsing USSR. In 1990, he left to study business at the University of Pennsylvania and founded an internet investment fund. He says he made some lucky early investments such as in Facebook, Twitter, Spotify, and Airbnb. He became aware of the dire conditions SETI was in and offered $100 million to fund his breakthrough initiative, an amount which seemed like small change for someone worth $3.8 billion. Sorry guys, I'm tired. Whew. I remember going to the launch press conference in London where Milner was flanked by Sagan's widow, Anne Druhan, Stephen Hawking, planet hunter Geoff Marcy, and Frank Drake. This is clearly the most comprehensive search yet carried out. It began in January 2016 and set to search for 10 years. Controversially to some, it is not based at California's SETI Institute but at the West Coast University of Berkeley. 1/3 of the money in the project is being used to purchase telescope time at the familiar Green Bank Observatory and the Parkes Observatory in Australia, where it is signed contracts for 20 and 25% of their available time respectively. Breakthrough Listen is looking at 1 million nearby stars in the centers of 100 galaxies. It is reported that the system could detect Earth leakage-like signals from about 15 light years and can detect a transmitter equivalent to an aircraft radar from the nearest 100,000 stars. In October 2016, the newly built 500-meter aperture spherical radio telescope FAST in China joined in. This telescope of the Arecibo type design that is built into the landscape and is currently the world's largest radio telescope. In December 2020, it was reported that in April and May of 2019, a narrowband signal in 982.002 megahertz was detected that displayed variations in frequency consistent with the movement of a planet around a star, in this case the closest star to the Earth, Proxima Centauri. No changes in the strength of the signal were detected, and it's been designated Breakthrough Listen Candidate 1. At the same time of writing, the researchers are yet to exclude terrestrial interference, but they don't think it's aliens. Breakthrough Listen is expanding its observatory. Breakthrough Listen is expanding its observatory. Is expanding its observing base by adding Meerkat, a South African array of 64 dishes, each 13 meters across. Instead of buying time, it was sampling its data stream while the telescope carries out its normal observations. Just like Serendip, the Carl G. Jaskin Very Large Array in New Mexico, the workhorse of U.S. radio astronomy will also be joining in. All of the data from Breakthrough Listen will be available to the public, 10 gigabytes per second, the largest amount of scientific data ever made available to them. We will be able to generate as much data in one day that will have taken previous SETI searches 1 year, Milner said. The hardware and the software used in the Breakthrough project will be compatible with other telescopes around the world, so they too can search for intelligent life, he added. As an inside, piggybacking radio observations is far from new. As a young radio astronomer at Jodrell Bank in the late 1970s and 1980s, I obtained my PhD by using the main telescope along with 200 kilometers away to look for explosions on the surfaces of nearby stars, a continuation of the observing effort Bernard Lovell mentioned in his reply to Konkani and Morrison. We were looking for flares, so we had the telescope set to a parcel, the data into 13-second chunks. Although we were not observing with a very few frequency range, we saw flares from some of the nearest red dwarf stars in the solar neighborhood. It occurred to me that I should look at the data for anything that might be suspicious alien-wise, so I wrote a few small computer routines to analyze the data, but nothing was seen. On another occasion, I took part in observing run looking for what is called Hawking radiation, which we will discuss later. Hawking radiation, yeah. Briefly, small black holes made when the universe was young, if they exist, should about now, 14 billion years later, be disappearing in a flash of radiation, including radio waves. So we used the Lovell dish to look towards the center of our galaxy, and in the opposite direction, as well as up and down from the galactic plane and up and down our galactic spiral arm. We found nothing at our level of sensitivity, either black hole flashes or alien signals. Otherwise, this would have been a very different look. There is another way to send signals between the stars. Because of bias and fashion, this method hasn't received its fair share of attention from those who prefer radio waves in their search for signals from space. This is the prospect that aliens might be sending laser signals towards us. When the laser signal was invented in 1960, during the time when the radio searches were becoming the big thing, it was dismissed as a curiosity that was barely able to produce a few milliwatts and something that would find few practical applications. Today, of course, lasers can be found everywhere. Using high-powered lasers, is it possible to swiftly transmit large amounts of data across interstellar distances? Today, the most powerful laser in the world has a power output of about 10 petawatts in pulses lasting a trillionth of a second. Chinese researchers are aiming to create a 100 petawatt laser in the near future. Its single pulse would be 10,000 times more powerful than all the electricity grids in the world combined, though, of course, lasting for a very brief time because they would extend out as briefly very different from starlight. Our lasers are already bright enough to be seen across interstellar distances, and we will even have detectors that can easily register pulses of just a billionth of a second. In the right circumstances, it is very possible to transmit the entire content of the U.S. Library of the Congress in just a few minutes using lasers. Lasers have other advantages as a medium for sending messages. They don't suffer from smearing of frequencies like radio waves, and although their beams broaden when beamed over interstellar distances, This spread, perhaps several 100 million kilometers, would be useful as it would bathe more than one possible planet with its light. As one would expect, there are some problems with using lasers, particularly when it comes to interstellar dust. But lasers tuned to infrared light can overcome such issues. In fact, the inventor of the laser, Charles Towns, realized that the universe was transparent to the infrared lasers up to about a few hundred light years. But that could be enough. Few interested in lasers for interstellar communication except Stuart Kingsley, who from the 1970s who disparagement from the radio optimist carried out observations using his own telescope. On one occasion, on a meeting in 1990, he was invited to speak at NASA's Ames Research Center and was told just about before his talk not to say something about the superior beaming capabilities of his laser. He ignored the advice and his argument was persuasive. With the radio drawing a blank, even Frank Drake became interested in lasers, leading a search in 1999 from the Lick Observatory in California, examining 5,000 stars for flashes of laser light over a decade. Nothing was found. Today, lasers, especially infrared ones, have just as much gratification behind them as tools of alien communication as radio waves, and perhaps in the future the way to go is to look for the short radio pulses and especially infrared laser bursts. There is a project called NIROSETI, Near Infrared Optical SETI, which is promising. If only it could be founded properly, perhaps there is a message waiting to be detected sent by aliens from a nearby planetary system who have tailored its properties to pass through interstellar dust and even through the possible atmosphere of water-rich world. With the technology we have, we can outshine our sun by thousands of times over thousands of light years. We may soon be doing this. Some believe that the Breakthrough Listen initiative is reducing the giggle factor and bringing SETI into the mainstream for reasons other than the money talks. Almost 3 decades after Senator Bryan in 2008, NASA held a workshop on the prospect of detecting alien technosignatures. It even awarded a grant along those lines, its first ever SETI-related grant not involving radio searches. Yuri Milner has certainly been busy in 2016. Stephen Hawking, and Facebook founder Mark Zuckerberg established the Breakthrough Starshot project to develop a proof-of-concept fleet of tiny interstellar probes called Starships. Minute devices attached to small solar sails and propelled by a laser fired at them. If the project works, they will be aimed at the Alpha Centauri system 4.4 light-years away. After the initiative was announced, a planet was found orbiting a star in the system, Proxima Centauri, around which it orbits in the so-called habitable zone, where conditions could be suitable for life. For the project to succeed, fundamental advances needed to be made in over 20 fields of engineering, exceeding the current limits of technology by a long way. The goal is to reach a speed about 20% of the speed of light, resulting in a 20 to 30 year journey to the star and 4 years of a return signal. The laser required to propel the starships would have to be a gigantic multi-kilometer phased array of steerable laser beams with a combined coherent power output of up to 100 gigawatts. Such beams will make the Earth visible at interstellar distances if aliens happen to be looking at us at the right time. Much has been said about humanity reaching the threshold of interstellar communications when we developed radio telescopes, our so-called entry to the potential galactic club. But what if that wasn't enough? What if there are other discoveries we make or technologies develop that are better thresholds? Could it be that developing radio telescopes isn't in itself enough, that aliens are waiting for us to pass further thresholds to open a new window to contact? We may just have done that. We may just have done that. Ripples. I'm gonna get comfy. Okay. We return to the question: Do signals from aliens? I'm gonna take this off, bro. It's just making my hair just Trash. That's okay. We return to the question: do signals from aliens crisscross the galaxy aimed at the star to candidate star? We know if some signals do. It came out of the darkness from the direction of a giant red star. It had been traveling through space for just about over 20 years, reaching the outer edge of the solar system. It encountered a disk of rocky and spicy debris containing about 10 times the number of comets found in our own solar system's Kuiper belt. Those comets, most of the time frozen in these cold outer reaches, only few would ever thought their orbits perturbed in such a way that they would find themselves approaching their star, becoming hotter and forming a transient tail of gas and dust, and perhaps delivering water to the inner worlds. A star like this one would have 2 billion years or so for a substantial amount of water to be delivered from the outer belts to the inner system, and of course, to any potentially habitable worlds that might reside there. The water flowing from the edge of the interstellar space would make all the difference. The star is not very bright as stars go and very young for its type. It's so-called red dwarf, low mass, about a third of our sun's mass, and low temperature. But we shall see later, it could be an example of one of the most promising places for life to develop in the universe, offering more places on longer timescales than worlds like Earth and the stars like our sun. The planets circling the red stars have masses between 2 and 15 times that of Earth, and all are located within 20 million miles of it. Although a Neptune class world further out is a possibility. Researchers using the Herschel Infrared Telescope in orbit, which is primarily sensitive to dust and warm gas, have detected a considerable amount of dust which they have attributed to cometary collisions, which could be triggered by a planet orbiting near the debris disk. From what we know, the inner worlds of the system might be suitable for life. If their inhabitants detected the signal we sent that flashed through the system and looked closely at it, they would see that it did not, in fact, come from a red supergiant star, but a smaller yellow one in almost the same direction, our sun. The Gliese 581 complex is the address of the interstellar message, a message from Earth and hello from Earth. But even if there were intelligent aliens in the system, and even if they had radio telescopes looking at the right time in the right direction and receiving the right frequency, would they have picked up the signal? Could any aliens have picked up any signal from us? How have we given the game away? Do they know we are here? A decade after the attempts to listen to Mars in 1924, the British Air Ministry authorized the secret construction of 5 tending stations along the east coast of England. Each was the use of radio beams in the microwave region of spectrum to sweep across the sky to warn of any surprise attack of Germany's new Luftwaffe. Later, a further 15 of these stations were installed, and during the war that followed, the system became known as radar. Radio transmitters and receivers of ever greater power and developed until, by 1996, it was possible to bounce radar signals off the moon. The first thing we went to touch the moon and the planets were radio waves. The first thing we sent to touch the moon of the planets were radio waves. Damn, I didn't know that. Sorry, guys, I'm tired. It's a little late. I got this. Let's go. Okay. One of the most powerful transmitting dishes was at the Millstone Hill in Massachusetts, and in February 1958 it was used to send radar pulses towards Venus, our near celestial neighbor after the moon. The output of the radio telescope was scrutinized as the time a reflection from Venus was expected, but it seemed it was all noise. No one was sure if the attempt had worked, so when Venus came close to Earth again the following year, another attempt was made, again with equivocal results. Success was achieved at the third attempt in 1961. A power of 12,600 watts was beamed toward Venus, of which, due to the dilution of the signal, as it propagated, only about 10 watts reached the planet, most of which was absorbed and only a fraction reflected back to Earth, where a hundredth of a billionth of a billionth of a watt returned to strike the waiting radio dish. However, such is the power of the radio astronomy and its ability to detect tiny signals, that the signal was still 10 times the level of the background noise, which meant it was easily seen. Soon, radar echoes were received from the sun and other bodies of the solar system. It was an initial demonstration of the principle of sending a message of the stars, and astronomers didn't wait long to didn't wait long in trying. Project Ozma had listened. Now it was time we spoke. The first message sent me into space, intended for extraterrestrial civilizations, was also used to test their radar telescopes' ability by once again bouncing the signal off Venus. It consisted of 3 words, all encoded in Morse code. The word mir, meaning both peace and the world in Russian, was transmitted from a radio telescope in Yevpatoria, Crimea on 19 November 1962, along with the words Lenin and USSR. Later, these words were beamed toward the multiple star systems that contained the red giant HD 131336, which is just over 1,000 light years away in the constellation of Libra, as is Gileas 581. You cannot see the rather undistinguishable star with the unaided eye, and although it had been catalogued, it had not been extensively studied. We have sent many messages to the nearest stars, at least 11 times, most of them promising candidates for life. Then HD 131336. Not all of them were serious attempts to send a signal to aliens. Far from it. They were gimmicks, and the best, they were more of a massage to ourselves. Most of the messages were sent from a radio telescope at Yevpatoria in Crimea. A powerful transmission was sent out on 16 November 1974 to celebrate the upgrading of the giant 305-meter diameter Arecibo Radio Observatory in Puerto Rico, which sadly recently collapsed in a spectacular fashion. Built in 1963, utilizing a giant sinkhole in the karst topography of the region. Its weird mesh surface was replaced by aluminum panels in the early 1970s. The director of Arecibo was none other than Frank Drake, who, with his assistant Jane Allen, came up with the idea of beaming a celebratory signal to the stars. Using the technique devised after the Order of the Dolphin Conference, they studied a message with a total of 1,679 binary digits, which, when arranged in a rectangle of 73 rows by 23 columns, revealed the pictorial message. It contained a lot of information. It began with a lesson in binary counting system, likely to be needed as binary is the simplest possible counting system, and then included the atomic numbers of the 5 elements that make up DNA, hydrogen, carbon, nitrogen, oxygen, and phosphorus, as well as the chemical formula of DNA and a diagram of the DNA helix. There was the population of Earth in 1974, 4.3 billion, and a rough graphic of a stick figure human. At the base of the pictogram was a diagram of the Sun and the 9 planets of the solar system, with the 3rd planet, Earth, standing out. The message ended with the graphic of Arecibo itself. It was sent to the Goldberg star cluster M13 purely because it was in the telescope's line of sight. As the instrument was built into the ground, it had very limited pointing ability. This was a demonstration of human technological ability rather than a serious attempt to contact aliens. M13 is a spherical group of ancient red stars about 25,000 light years from Earth on outskirts of our galaxy. It's among the oldest objects in the universe. It was by many years before another radio message was beamed towards the stars, and some of these could only be described as bad jokes at best. In 1999, the RT-70 planetary radar dish at Yevpatoria was again in action, sending 2 sets of messages to nearby stars. Cosmic Call 1 in 1999 and Cosmic Call 2 in 2003. They repeated the Arecibo message and added a further message in a language called Linkos, which had been devised in 1960 by the mathematician Hans Freudenthal by potential use in communicating with an alien civilization. It used mathematical rules instead of human syntax. The aim was to send a Linkos dictionary. what the astronomers involved called the interstellar Rosetta Stone along with their message. These attempts at communication were a short-lived affair at the Texas-based startup behind them so quickly went out of business. At about the same time, there was also the so-called Teen Age Message, a series of transmissions from Ypsistoria to six sun-like stars in the autumn of 2001. The content was chosen by a group of teens from 4 Russian cities and included a live theremin concert as well as images and text. In 2008, the song Across the Universe by the Beatles was transmitted by NASA in the direction of the star Polaris by a 70-meter dish near Madrid, which is a part of a deep space network. It was to mark the 40th anniversary of the song's recording and the 5th anniversary of NASA. Lone Signal was a crowd-funded project based on the Jamesburg Earth Station in California. On 17th June 2003, it transmitted 144 character messages to the red dwarf star Gliese 526, some 17.6 light-years away. Due to the lack of money, transmission ceased soon after it began. Arecibo was back in action in 2012, on the 35th anniversary on the WOW signal. This time it transmitted 10,000 Twitter messages towards the stars Hipparchus, 345 and 11. Why am I reading that wrong? 34,511, 33,277, and 43,587. A later transmission called A Simple Response to an Elemental Message consisted... I'm going to read it like this. Response to element consisted of 3,775 replies to the question, how will our present environmental interaction shape the future? A so-called message in a bottle was transmitted in October 2016 by the European Space Agency's Cerebros Deep Space Tracking Station, again towards Polaris, approximately 434 light-years from Earth. And shortly afterwards, a message from Earth was beamed to Gliese 581. Leighton Star, another red dwarf 12.4 light-years away, was sent messages in 2017 and 2018. It was at the time known to be home to one planet. These messages are, to be candid, a Morley collection. Nobody has been in charge of sending such messages, and there are no rules others have success of a suitable equipped radio telescope. There are some limp international protocols about signals from Earth, but they are ignored if they are even known at all. At these signals were a serious attempt to represent humanity to the cosmos. Then we should, as a species, bow our heads in embarrassment of not shame. It is therefore good that they are all irrelevant, as we shall see. Some maintain we are placing ourselves in danger. Jared Diamond, professor of evolutionary biology and Pulitzer Prize winner, said, those astronomers now preparing again to beam radio signals out to hoped for extraterrestrials are naive, even dangerous. Some say the vastness of space will protect us and that aliens would be far too away, to be a threat to us. But this is no counter-argument at all, as we might be lucky and find an alien source much closer. When I was a young scientist at Georgewell Bank, I asked Sir Bernard Lovell about aliens. He had thought about aliens often, even before he received the now famous letter from Cockney and Morrison. He replied, it's an assumption that they will be friendly, a dangerous assumption. While I was discussing the issue with the late influential astronomer Zdeněk Koupil, he grabbed me by the arm and said in a serious tone, should we ever hear the space phone ringing? Should we ever hear the space phone ringing, for God's sake, let us not answer. We must avoid attracting attention to ourselves. The opinion that it is dangerous to assume that aliens are friendly is held by many leading scientists in the field. Physicist Freeman Dyson, formerly of the Institute for Advanced Study in Princeton, said, it is unscientific to impute to remote intelligences wisdom and serenity, just as it's to irrationalize and murderous impulses. The Nobel Prize winning American biologist George Wald took the same view. He said he could think of no nightmare so terrifying as establishing communication with a superior technology in outer space. Carl Sagan also worried about so-called first contact, advising that we should listen for a long time before taking any action. He added that there is no chance that two galactic civilizations will interact at the same level. One will always dominate the other. There's also the saying that it takes two to be friends, but only one to make war. Others have put it more graphically, saying that the civilization that blurts out in existence might be like some early hominoid descending into the trees and calling "Here, kitty" to a saber-toothed tiger cat. To a saber-toothed tiger. However, Frank Drake is less worried. Let me sit up. However, Frank Drake is less worried. As I thought in 1974, the objections to sending interstellar messages were naive and carried no weight. The argument then, as now, is that humanity has been and is making its presence known through our TV and radio military radars, which, in many cases, release most of their radiated power into interstellar space. Science fiction. Into interstellar space. Science fiction. Oh. It looks like 30 minutes is up. See you guys. That was day 35 of reading every single day for the rest of my life. We are at page 112. Middle of page 112. And yeah, see you guys in day 36. Let's go.